Assalamu alaikum, dear students. In today's class, we will discuss about other type of data structure. Today class is very important because this type of data structure we are mostly using in scientific analysis, whether it is related to biology, it is related to chemistry and other and also related to other fields. So today we will discuss about data frames. Okay, that what is data frames? In the previous class, we discussed about matrices, we discussed about vectors, we discussed about other data structure. So today we will discuss that what is data frame and how it is different from matrices and how to work with data frame using some simple examples. Okay. So data frame, it is like a table or two-dimensional array, two-dimensional structure in which each column contain value of one variable and each row contain one set of value from each column. Don't be confused that whenever we are analyzing data in Excel sheet, so that Excel sheet, it is a data frame because we have some specific row names and we have some specific columns names. Okay, but there are some rules and R, whenever you are doing such type of analysis in R, so there are few rules, you have to follow those rules. Okay, the first one, the column names should be non-empty. There will be always some columns names because if you keep one column empty, then it will show error. Okay. The second one, same, the row names should be unique. Okay, this is the second point, that for example, if your structure, if your data have 5 columns and 5 rows, so these names should be unique. If these are similar to each other, then also it will show error that your data has duplicated row or duplicated columns. Okay. The third one, the data will be numeric, vector or character data type. Okay, so the data will be numerical or it will be maybe an character or string type, and that can be a vector. The fourth one, the each column should contain same number of data items. Now I will explain that how, because if one column have 4 data, like for example 4 data type, so the other column also will be 4. If the other column is 4, 3 or 5, so then it will show error because then you cannot analyze it because then there will be one column empty. So that's why each column should contain same number of data items. Okay. Now, how to create a data frame? That if you want to create a data frame in an Excel sheet from the beginning, so how you will create that data frame? For example, I want to create the data frame. Okay. So I will give this data frame or this variable a name treatment data. Okay, this is, you can give any name. Okay, I gave this variable name treatment data, then I will put this sign. Now, in the previous class, if you remember that we put list, we put matrix here in this section, but here today we are making data frame, so here we will put data frame. Okay, I will put data frame. Okay, now you should mention the column of your data. Okay, for example, you can make enter here, no problem. Like you can do it in multiple lines, so there will be no issue. For example, treatment is my first column. Okay, and this treatment contain, I will put C here. Why? Because I want to combine data in one column. So I will start a bracket, then I will put this double quote, because now, why I put double quote? Because now I want to enter character data here. Okay, so for example, the first treatment will be control. Okay, the second treatment will be, for example, NaCl. Remember that in this data frame, I will create a data related to biological experiment, which is related to NaCl or salt stress. Okay, so the second treatment will be NaCl, then comma, then the third one will be NaCl, and for example, we use some hormones. Okay, this is the third treatment. Then the fourth one will be NaCl, and then we use some bacteria. Okay, then the fifth one, we will also add, the fifth treatment is cadmium. We also want to check the cadmium experiment here, that this is a combined experiment, cadmium plus salt. Okay, so we will use cadmium, and similar treatment we will apply, for example, cadmium hormones. Okay, again cadmium, bacteria, okay. You can, don't be confused in this one, because you can make it according to your own analysis, according to your own data structure. Now you can see, I want to make a data frame, and this data frame, this is the column name. The column name contain treatment control, NaCl plus hormone, NaCl plus bacteria, cadmium hormones, and cadmium plus bacteria. Then I will put comma here. I will put enter here, because I don't want to enter. I don't want to enter here, because then you cannot see it. So that's why I put enter here. Okay. So when you put enter, so you can write here. Okay. So now this is the first column. Okay. Now the second column should be, okay, 1 minute. Yes, the second column should be, for example, in this experiment we want to check shoot length. Okay, shoot length. So the shoot length will be is equal to, like I did this one, you will do the same. Okay, so I will put C, and then I will start bracket. So for example, there will be some value for the shoot length. For example, 25, then comma 13, then comma 18, then comma, 17, then comma, 10, then comma, 15, then comma, 13. Because these should be equal to this 1, 2, 3, 4, 5, 6, 7. We have 7 treatment. So 1, 2, 3, 4, 5, 6, 7. So we will put 7 values. Okay. Now we will put comma and again I will enter it. Now the second parameter I want to check root length. Then is equal to, then I will put C. Okay. Now I will put root length values, for example 23, then 15, then 16, then 18, then 12, 14, 15. Okay. Now we have both shoot length and root length data. Okay. The third one, I will put number of leaves, for examples, number of leaves. So I will put C here the same, and the number of leaves should be, for example, 8, 5, 6, 6, 8, 3, 2 and 3. Okay. Other one, we can add other parameter, for example, you can say stem width. Okay. If you want to say anything, okay, just tell me. Otherwise, you can mute your mic. Okay. Then the stem width, we will, for example, the stem width, for example, 6, then 5, then 8, then 5, then 4, then 1, 2, 3, 4, 5, 6. Okay, and one more. Now this is the data frame I created. Okay. Now in this data frame, the data frame will be saved in treatment data, and this data frame will have 4 columns. The first column will be treatment, the second column will be shoot length, the third column will be root length, the fourth column will be leaves or number of leaves, you can rename it, and the fifth column will be stem width. Okay. So this is the data. Okay. So now, for example, if I run this script, so it run. So you can see here in this portion, this is the environment portion. So this data frame, it is created. It means that we have 7 observation and 5 variable. It means we have 7 treatment and 5 columns, 5 parameters, okay, including the treatment one. Okay. So now how you can check this data, that what is inside the data and how it look like. Okay. So for that one, I will enter here and I will put, for example, I will make it easy for you, that print data frames. Okay. That how we will print data frame. So you can use print command, print. Okay. When print command, because we save this data in this data treatment data, so you can copy or you can write it, no problem. Okay. I will paste it here. So now if I run this, so it will show me the data. So now you can see here that the data arranged in like an Excel sheet in a data frame. Okay. In this data we have treatment, control, NaCl plus hormones, NaCl plus bacteria, cadmium plus hormone, and cadmium plus bacteria. Here you can see the shoot length, you can see the root length, you can see number of leaves, and you can see stem weight. So by this way you can create a data frame in R. Okay. This is the way that how you can manipulate data, how you can make changes in your data. Otherwise, if you have Excel sheet, if you have CSV file, you can also import that data to Excel sheet that we will discuss in our upcoming classes. Okay. Today we don't, we will not discuss that. Today we will discuss that how we can create a data frame in R and how we can make changes in that data frame. Okay. So in this one, you can see here the print. It show that our data is it look like this. Okay. Now, what we can do? What we can do? Like for example, if we want to check the data, the structure of this data, that what is the structure and the structure of this data. For example, the structure, so for the structure we will use str. Str means structure. Okay. And then we will use the same data, this, that I want to check the structure of this data. Okay. So if I run this command, so you can see here this one, the structure of data mean that you want to check that your data is numeric, that your data is string data, that your data is Boolean data, what type of data you are analyzing. So you can see here that our data frame have 7 observation, okay, 5 variable. The treatment is like character data. They show that the treatment column is character data. Okay, that's why we put this double quote here. Okay, because this is character data. Okay, then the shoot length, it show that it is numeric data. The root length also numeric data, leaves also numeric data, and stem width also numeric data. So by this way, you can extract, you can get information about the structure of data frame. Okay. Now, for example, if you want to check the summary of this data, okay, that how to check the summary of this data. So for example, print, I will use print command, and then I will use summary. Okay, summary you can see here, and then I will again put the treatment data. Okay, now I want to check, because if you have, this is a very like you can say that very small data frame, but if you have more data frame with 1000 of rows, 1000 of columns, then these commands will definitely help you in your data analysis. So for example, if I want to print the summary of this data frame, so if I run this command, you can see here the full summary, that the treatment, you can see shoot length, root length, fresh weight. Okay, minimum, the shoot length minimum is 10. Okay, median is 15, mean will be 15.86, and maximum will be 25. Okay, so like it is mean, maximum, median, first quartile, all these you can get from by using this, by the summary command, that what is your maximum value, what is your minimum value, what is your mean. Okay, so this will work in your statistical analysis, and it will help you when you are writing your result, when you are writing your discussion section. So it will help you, and it will summarize your table, and you can easily write your results. Okay, now what we can do, some other you can say that option we can try. For example, I want to extract data from this data frame. For example, if you have, this is as I mentioned before, this is not a big data frame, and we have very few columns and rows. But if you have a bigger data set, so then how can you extract some data? If you want, for example, if you want to target one column, if you want to target one treatment, that how you will get that data from your big data sets. Okay, so for example, if you want to extract, we will just result, and we will give name to this result extract. Okay, you can give any name to this, and then what you will do, that we want data frame, because we want to extract from data frame result. So from data frame, what you will write here, that the name of the data frame. What is the name of the data frame? The name of the data frame is treatment data. This is the name of your data frame, because here you can see we give this name to the data frame. So here you will put the name of the data frame, then you will put this dollar sign. Okay, this dollar sign will check, it means that you want to check something inside the treatment data. Okay, so what you want to write here, because I want to target the treatment column. Okay, and then you will put the comma, date, and again you will put the treatment data, sorry, the treatment data, and again you will put this sign. Okay, and now the first one, this one, we give this command that I want to extract data targeting the treatment column, and then the second one, I want to extract data from this data set. Now you can choose your column. Okay, either you should need shoot length data, you need root length data, you need number of leaves data, or you need stem width data. So for example, if we want leaves data, okay, I want to only extract this type of data from this data set. So if I run this command, so now you can see here result extract this one, because this is a variable, we can store data, this is a container. So now we have two container, one is this one, and this data and this treatment data you have all data. Okay, and one is this one, result extract, and this one you have only two variable. Okay, and 7 observation, it means 7 treatment, but only 2 columns will be there. Okay, so if I want to check the data that I need this result, I want to check this result, so I will use print command, and then I will write result extract. Okay, so you can see here that if I click this, so you can see that all other, the R program ignore the other columns and only focus on only extract data from this leaves column. Okay, so by this way, for example, you have, if you have a bigger data set, an Excel form and CSV form, and you don't need to separate it for one graph in R, because if you are making graph with origin, if you are making graph with the Excel sheet itself, graph pad, so then you have to separate these graph. For example, the leaves and treatment will be another separate, the shoot length will be separate, but R you don't need to separate it. You can use only one Excel sheet, and you can use different graphs from the same Excel sheet with this extract data command. Okay, so by this command you can extract any type. For example, if I want to change it to shoot length, that I need this data, so I run this command, and if I check, so yeah, now you can see that we have only shoot length data here. Okay, so this is how to extract data from a data frame. Okay, now the other thing, for example, that how to add, for example, how to add new column. to your data. For example, if you have Excel sheet and you are already working in R and you want to add one extra column, for example, to this Excel sheet or this CSV file or this data frame. So what you will do that for that one, for example, we will first write the treatment data. It means that you want to make changes in this data frame. Then I will put this dollar sign. Okay, so when I put dollar sign, so it automatically now it show me that you want to make changes in root length, shoot length, threshold, but no, I want to add another column. Okay, so another column will be related to experiments. So what we can do, for example, we will add, for example, chlorophyll contents. Okay, that I want to add one column, more column, which is by name chlorophyll contents. Okay, and then I will put this sign here. Okay, it mean that I want this dollar sign mean that I want to add one column to this data frame. Okay, now what will be the value in that column? What would be the values in that column? So I will put here C. Okay, and then I will start bracket, and then for example I will put any like 33, for example 22, 56, 2, 3, 4, 5, 6, and then 7. It, but remember one thing, that these values should be equal to your number of observation, because if I added 6 values, so then the R will be confused that you want to add this data to which treatment. But if we give the exact data, so then the R will know that you want to add this data in a like in the same way as you mention in the data frame. Okay, यहाँ पे I will explain in this in Urdu. इसको हम जब ऐड करना चाहते हैं अपने एक्सेल शीट में या डेटा फ्रेम में, तो इसकी वैल्यू फॉर एग्जांपल 1 2 3 4 5 6 7 7 ये इक्वल होनी चाहिए आपके पास जो ट्रीटमेंट है. ओके, अगर आपके पास ट्रीटमेंट 6 है और आपकी वैल्यूज 5 है तो ये तो नहीं हो सकता ना, क्योंकि एक्सपेरिमेंट तो इस तरह हो ही नहीं सकता. जब भी आप एक्सपेरिमेंट करते हो, अगर वो क्लोरोफिल कंटेंट हो, वो एंटीऑक्सीडेंट हो, जो भी हो, वो जितनी भी ट्रीटमेंट होती है सबकी वैल्यूज उसमें लगते हैं ना. तो इस वजह से the same value will be added there. Okay, so now we can, if I run this command, for example, okay, so if I run this command, for example, so you can see that like the chlorophyll contents that we will use this data frame and this chlorophyll this data set. For example, I will add one more thing, that treatment. I will check this now. Okay, is okay, so it is not added there. I think there maybe there will be some error that the treatment data, for example, I will run this command again, the treatment data. This is the logical 0, this command. Okay, it show error. So sometime whenever you are doing this type of analysis, so you will face such error that it will not work. Okay, so I will show you that why it is not working. Okay, but by this way you, okay, so if you can see any error in this one, oh, sorry, again we are receiving the same problem. treatment data. Okay, 1 minute. I will put this treatment, treatment treatment data, and then we will put this command here as data frame. Okay, I will put this command as data frame, and then we will see that what it shows. So logical treatment. Okay, this is the doubling. Hmm? No, I think this is not. We will maybe we use something that is not. Where is where? Hmm? Hmm? Mm, no, this is not. For example, we will change this by ABA. For example, ABA contents. We will check this. I will copy this. Treatment data, and we will print the treatment data. Then again we will use treatment data. Okay, now we will add it. Okay, actually in R, whenever you are doing whenever you are analyzing something in R, you face a problem. So for example, this is a common problem in R, that when you, for example, run this script, so it will store data in this command. Okay, but if you make some changes here, for example, and if you make some changes here again and with the same name, so then it will take the second, the like the final data. Okay, then it will consider your data frame as the previous one. So that's why, for example, that's why you have what you whenever you are facing this problem in R, you have to rerun. You have to rerun your script. Okay, when you rerun your script, so then it will make, like for example, I rerun this one. Okay, and now because the same thing I use, I didn't change anything. So then I the treatment data, I want to make ABA column, and then uh, this one I use this treatment data as an S container. Okay, and I want to change to see the S. For example, print print S. So if you check here, you print S, your column, this column, ABA column is added there in the data frame. Okay, so by this way, sometime you are facing this problem in R with only one small comma, small mistakes, so it will show error. Okay, this is a common thing in R, but then you have to again run your script, so then you will get your result. Okay, so for example, that this is like how to add column, and then for example, if you want to remove column, then you can also remove column from your data frame. So this is because I have only a few minutes remaining, so that's why I want to just speed up this lecture. So by adding such column, that if you want to add other column, you can add, but one thing you should remember, that these values should be similar in number of the treatment. Okay, and for example, that if you want to to visualize some data, I don't want to to start visualization, because for that we will make a separate lecture. But if you want to visualize or plot this data as a bar graph, as a pie chart, so you can visualize this data in an easy way. Okay. So now the column addition also we have done, and we have also, if you want to add row, you can also add row like as we did in our previous lecture in the matrix with this option or bind, row bind. You can add row to this. But usually whenever we are using this R program for our biological data analysis, we don't need to make to add column, add rows in R, because we already have our data in Excel sheet and CSV form. So then you can you can use that file in your R, and I will show you that how to use the date file in R, how to import your Excel file, and how to import your CSV file to R, and then you can make changes, and you can analyzing your data. But this is only that you should know that how to make changes in this data, and how to extract different type of data from a data frame. Okay. So for today I think this is enough, and for next in the next class inshallah we will discuss about very important topic, which is about R packages, that how to install R package, and how to execute R package, and how to use different type of R packages for different type of analysis. Okay. So from R packages actually we will enter to the real R programming, and that how we can install for example, for data visualization we are using ggplot. For statistical analysis we are using different packages. So inshallah in the next class we will discuss how to install R package, and how to execute, how to activate R packages in R. So inshallah we will discuss in the next class. For today, thank you very much.